Section 2 of In Time of Emergency, A Citizen's Handbook on Nuclear Attack, Natural Disasters, by United States Office of Civil Defense. This LibriVox recording is in the public domain. Nuclear Attack. A nuclear attack against the United States would take a high toll of lives. But our losses would be much less if people were prepared to meet the emergency, knew what actions to take, and took them. A nationwide civil defense system now exists in the United States and is being enlarged and improved constantly. The heart of this system is fallout shelter to protect people from the radioactive fallout that would result from a nuclear attack. The system also includes warning and communications networks, preparations to measure fallout radiation, control centers to direct life-saving and recovery operations, emergency broadcasting stations, local governments organized for emergency operations, large numbers of citizens trained in emergency skills, and U.S. military forces available to help civil authorities and the public in a time of emergency. If an enemy should threaten to attack the United States, you would not be alone. The entire nation would be mobilizing to repulse the attack, destroy the enemy, and hold down our own loss of life. Much assistance would be available to you, from local, state, and federal governments, from the U.S. Armed Forces units in your area, and from your neighbors and fellow Americans. If an attack should come, many lives would be saved through effective emergency preparations and actions. You can give yourself and your family a much better chance of surviving and recovering from a nuclear attack if you will take time now to understand the dangers you would face in an attack, make your own preparations for an attack, learn what actions you should take at the time of attack. Chapter 1. Checklist of Emergency Actions. Know your local emergency action plan. Find out from your local government your local plan for emergency action. Determine the specific actions you and members of your family are expected to take. Understand nuclear attack hazards. See Chapter 2. On the widespread threat of fallout, remember, the most dangerous period is the first 24 hours after fallout arrives, but you might have to use fallout shelter for up to 2 weeks. Highly dangerous amounts of fallout are visible. They look like particles of sand or salt. There is little danger that adults could inhale or swallow enough fallout particles to hurt them. Small children, however, could be injured by drinking contaminated water or milk. A person exposed to fallout radiation does not become radioactive. Radiation sickness is not contagious. One person cannot catch it from another person. Know the attack warning signal. See Chapter 3. On outdoor warning devices, the attack warning signal is a 3 to 5 minute wavering sound, or a series of short blasts on whistles or horns. This signal means an enemy attack against the United States has been detected. Take protective action. This signal has no other meaning and will be used for no other purpose. On warning, don't use the phone. Get information from radio. Know the location of fallout shelter. See Chapter 4. Public shelters are marked like this. Reader's note. Diagram contains a black circle in which there are 3 equilateral triangles, evenly spaced, with each triangle's vertex meeting at the center of the circle and the other 2 vertices touching the circle itself. Below the circle containing the triangles are the words fallout shelter with 2 arrows beneath the words pointing to the right. End of reader's note. Good shelters can be prepared in homes with basements. If no shelter is available, improvise protection. See Chapter 5. Remember, a basement corner below ground level or a storm cellar is the best place to improvise fallout protection. For the best possible protection, use heavy and dense materials for shielding. Prepare emergency supplies. See Chapter 6. Especially important are water and other liquids, food requiring no cooking, special medicines. Conserve emergency supplies. Maintain sanitation. See Chapter 7. Reduce fire hazards. See Chapter 8. Know the basics of emergency medical care. See Chapter 9. If no doctor is available, especially important are actions to restore breathing, stop serious bleeding, treat for shock, treat broken bones and burns. Follow official instructions. Chapter 2. Understand the hazards of nuclear attack. Summary. 1. The main hazards of a nuclear attack are blast, heat, fire, and fallout radiation. 2. You may be able to protect yourself against blast and heat by getting inside a shelter or taking cover before the nuclear explosions occur. You may be able to avoid fire injuries by putting out small fires or escaping from large fires that might occur in your area. 3. You can protect yourself against fallout radiation by getting inside a fallout shelter, if possible before fallout particles begin drifting down, and by staying there until you are told to come out by authorities who have the equipment to measure radiation levels. 4. After a nuclear attack, food and water would be available to most people, and it would be usable. If any fallout particles have collected, they could be removed before the food is eaten or the water is drunk. People suffering from extreme hunger or thirst should not be denied food or water, even if the available supplies are not known to be free of fallout particles or other radioactive substances. 5. Infants and small children should be fed canned or powdered milk, if available, for a while after the attack, unless the regular milk supply is uncontaminated. They should not be given water that may contain radioactive substances, if other water known to be pure is available. 6. A person cannot catch radiation sickness from another person. Understand the hazards of a nuclear attack. When a nuclear bomb or missile explodes, the main effects produced are intense light, flash, heat, blast, and radiation. How strong these effects are depends on the size and type of the weapon, how far away the explosion is, the weather conditions, sunny or rainy, windy or still, the terrain, whether the ground is flat or hilly, and the height of the explosion, high in the air or near the ground. All nuclear explosions cause light, heat, and blast, which occur immediately. In addition, explosions that are on or close to the ground would create large quantities of dangerous radioactive fallout particles, most of which would fall to Earth during the first 24 hours. Explosions high in the air would create smaller radioactive particles, which would not have any real effect on humans until many months or years later, if at all. Footnote: These smaller particles would drift to Earth more slowly, losing much of their radioactivity before they reached the ground, and would be spread by the upper winds over vast areas of the world. End footnote. What would happen in an enemy attack? If the U.S. should be attacked, the people who happened to be close to a nuclear explosion, in the area of heavy destruction, probably would be killed or seriously injured by the blast, or by the heat of the nuclear fireball. People a few miles away, in the fringe area of the explosion, would be endangered by the blast and heat, and by fires that the explosion might start. However, it is likely that most of the people in the fringe area would survive these hazards. People who were outside the fringe area would not be affected by the blast, heat, or fire. Department of Defense studies show that in any nuclear attack an enemy might launch against us, tens of millions of Americans would be outside the fringe areas. To them, and to people in the fringe areas who survive the blast, heat, and fire, radioactive fallout would be the main danger. Protective measures against this danger can be taken. What is fallout? When a nuclear weapon explodes near the ground, great quantities of pulverized earth and other debris are sucked up into the nuclear cloud. There, the radioactive gases produced by the explosion condense on and into this debris, producing radioactive fallout particles. Within a short time, these particles fall back to Earth, the larger ones first, the smaller ones later. On the way down, and after they reach the ground, the radioactive particles give off invisible gamma rays, like X-rays, too much of which can kill or injure people. These particles give off most of their radiation quickly, therefore the first few hours or days after an attack would be the most dangerous period. In dangerously affected areas, the particles themselves would look like grains of salt or sand, but the rays they would give off could not be seen, tasted, smelled, or felt. Special instruments would be required to detect the rays and measure their intensity. Fallout would be widespread. The distribution of fallout particles after a nuclear attack would depend on wind currents, weather conditions, and other factors. There is no way of predicting in advance what areas of the country would be affected by fallout, or how soon the particles would fall back to Earth at a particular location. Some communities might get a heavy accumulation of fallout, while others, even in the same general area, might get little or none. No area in the U.S. could be sure of not getting fallout, and it is probable that some fallout particles would be deposited on most of the country. Areas close to a nuclear explosion might receive fallout within 15 to 30 minutes. It might take 5 to 10 hours or more to drift down on a community 100 or 200 miles away. Generally, the first 24 hours after fallout began to settle would be the most dangerous period to a community's residents. The heavier particles falling during that time would still be highly radioactive and give off strong rays. The lighter particles falling later would have lost much of their radiation high in the atmosphere. Fallout causes radiation sickness. The invisible gamma rays given off by fallout particles can cause radiation sickness, that is, illness caused by physical and chemical changes in the cells of the body. If a person receives a large dose of radiation, he will die. But if he receives only a small or medium dose, his body will repair itself and he will get well. The same dose received over a short period of time is more damaging than if it is received over a longer period. Usually, the effects of a given dose of radiation are more severe in very young and very old persons, and those not in good health. No special clothing can protect people against gamma radiation, and no special drugs or chemicals can prevent large doses of radiation from causing damage to the cells of the body. However, antibiotics and other medicines are helpful in treating infections that sometimes follow excessive exposure to radiation, which weakens the body's ability to fight infections. Almost all of the radiation that people would absorb from fallout particles would come from particles outside their own bodies. Only simple precautions would be necessary to avoid swallowing the particles, and because of their size, like grains of sand, it would be practically impossible to inhale them. People exposed to fallout radiation do not become radioactive and thereby dangerous to other people. Radiation sickness is not contagious or infectious, and one person cannot catch it from another person. Protection is possible. People can protect themselves against fallout radiation and have a good chance of surviving it by staying inside a fallout shelter. In most cases, the fallout radiation level outside the shelter would decrease rapidly enough to permit people to leave the shelter within a few days. Even in communities that received heavy accumulations of fallout particles, people soon might be able to leave shelter for a few minutes or a few hours at a time in order to perform emergency tasks. In most places, it is unlikely that full-time shelter occupancy would be required for more than a week or two. Many kinds of fallout shelters. The farther away you are from the fallout particles outside, the less radiation you will receive. Also, the building materials, concrete, brick, lumber, etc., that are between you and the fallout particles serve to absorb many of the gamma rays and keep them from reaching you. A fallout shelter, therefore, does not need to be a special type of building or an underground bunker. It can be any space, provided the walls and roof are thick or heavy enough to absorb many of the rays given off by the fallout particles outside, and thus keep dangerous amounts of radiation from reaching the people inside the structure. A shelter can be the basement or inner corridor of any large building, the basement of a private home, a subway or tunnel, or even a backyard trench with some kind of shielding material, heavy lumber, earth, bricks, etc., serving as a roof. In addition to protecting people from fallout radiation, most fallout shelters also would provide some limited protection against the blast and heat effects of nuclear explosions that were not close by. Chapter 4 discusses the various types of fallout shelters that people can use to protect themselves in case of nuclear attack. Food and water would be available and usable. From many studies, the federal government has determined that enough food and water would be available after an attack to sustain our surviving citizens. However, temporary food shortages might occur in some areas, until food was shipped there from other areas. Most of the nation's remaining food supplies would be usable after an attack. Since radiation passing through food does not contaminate it, the only danger would be the actual swallowing of fallout particles that happen to be on the food itself, or on the can or package containing the food, and these could be wiped or washed off. Reaping, threshing, canning, and other processing would prevent any dangerous quantities of fallout particles from getting into processed foods. If necessary to further protect the population, special precautions would be taken by food processors. Water systems might be affected somewhat by radioactive fallout, but the risk would be small, especially if a few simple precautions were taken. Water stored in covered containers and water in covered wells would not be contaminated after an attack because the fallout particles could not get into the water. Even if the containers were not covered, such as buckets or bathtubs filled with emergency supplies of water, as long as they were indoors, it is highly unlikely that fallout particles would get into them. Practically all of the particles that dropped into open reservoirs, lakes, and streams, or into open containers or wells, would settle to the bottom. Any that didn't would be removed when the water was filtered before being pumped to consumers. A small amount of radioactive material might dissolve in the water, but at most this would be of concern for only a few weeks. Milk contamination from fallout is not expected to be a serious problem after an attack. If cows graze on contaminated pasture and swallow fallout particles that contain some radioactive elements, their milk might be harmful to the thyroid glands of infants and small children. Therefore, if possible, they should be given canned or powdered milk for a few weeks if authorities say the regular milk supply is contaminated by radioactive elements. In summary, the danger of people receiving harmful doses of fallout radiation through food, water, or milk is very small. People suffering from extreme hunger or thirst should not be denied these necessities after an attack, even if the only available supplies might contain fallout particles or other radioactive substances. End of section 2.